Hi guys, we are here today to talk about radical functions, not rational, but radical functions. And this activity goes with the document that I have posted for you. So let's start in Desmos, shall we? So let me share my screen and we will take a look at what these graphs look like. Okay, so first and foremost, if you don't know where the square root key and the cubed root key and all the other fancy roots that show up on this document, so the square root key is right here on your normal keyboard. You just hit that and that's a square root of x. But then the cubed root, or any other root for that matter, you have to go into functions right here, FUN functions. And then you're going to choose the miscellaneous tab. It's the tab all the way to the right. And then right here in the middle column, that's where you'll see what we call the nth root button. So if you hit that button, this is where you have the ability to tell Desmos that what you want for that first question on the activity is the cubed root. So you put a little 3 up there, and that means cubed root. And of course, the cubed root of x. So certainly you have a feel for what the graph looks like, but your document obviously wants you to make a table for very specific values. So to do that, remember, you can just hit the wrench right here and then push the little table feature, and it will populate a table for you. And then once you're in that table, you can change it to whatever you need it to be. So you can fill in the values that you need based on whatever the table asks you for. And then if you want to do the same thing for the other formula, you'll just hit the little wrench again and scroll down to where the other function is and hit table once again, and it populates a table for you, and you can then type in the numbers that you need. Now, I already have this filled out just because I don't want to sit there and type it. You guys can go in and type it yourself. But these are the table values that you should hopefully get. And so you can, please make sure you type this in yourself and make sure that you get the same answers as me. But these are the values that you should get when you type in the formula. The top line is the square root function, that's f of x. And the bottom line is the g of x function. Now, the next questions are about domain and range. So remember that when we say domain and range, what we're referring to are the valid. When we say domain, we mean the valid values of input for each function. So for this first function, the square root, that was the f of x, you can see that not all the values are valid. You get undefined, 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 and then eventually you do get an answer. So your job is to be able to communicate, where is it valid? Is it valid at -10? No, then that's not in your domain. Is it valid at -4? No. Is it valid at -1? No. Is it valid at 0? Yes. What about after that? Is it valid at 1, 2, 4, 10? So it seems to be valid only for points 0 and above. Anything below 0, not so much. Those were not valid. But values from 0 and above do seem to work. So your domain goes from 0 and above. So you can just say x is greater than or equal to 0, or you could compound that with infinity. I'll go back and show you my document in a second. Now the range, remember, the range is just valid values once again, but this time for the output. So if you look at the types of answers that you got as your outputs, what types of numbers were you getting as your answers? Were you getting negative answers? No. Were you getting positive answers? Yes. And so you can see from the graph too, that this graph only occupies what we would call the first quadrant. The upper right-hand section of the graph paper, that's called the first quadrant. That's your all positives, positive x, positive y. And that is definitely where this graph lives. So that particular graph, its domain, oops, wrong one. Its domain has to be positive, but also so does its range. Oops, that is not what I wanted. Let's see if I can put a little box around it. So the domain was all positives, and so was the range. Here we go. So the domain for f of x is positives only, and so is the range of f of x is positives only. Now we'll come back and we'll elaborate on that in just a second, but let's go look at the other function really quick. So the other function, the cubed root, so when you start to think about what was valid on that graph, well, were negatives valid? Do you have any error messages right now? No, no error messages. So are negatives valid? Yes. Is 0 valid? Yes. Are positives valid? Yes. So what seems to be valid on this graph? Everything. There's nothing invalid. There's no error messages. There's no undefined. Nothing seems to be invalid, which tells you that everything must be working. And remember, the quick way that we say that is all real numbers. And what about the range? Look at the answers that you got. Did you get some negative answers? Yeah. Did you get some positive answers? Yeah. Could you plug in 0 and get a result? Yeah. So what was valid in terms of the outputs? Everything. Everything seems to be working. I have no errors. And if you look at the graph, I'm up here in the positive quadrant. The upper right-hand quadrant is all the positives. Yep, those are there. Then also look down here. The green graph is also in the negative quadrant. That's quadrant 3. So I got some positives, I got some negatives. Everything, guys, everything is working. So the way that we say that is all real numbers. Now, with regards to why this is happening, so as you can see, my g of x, the domain is all real numbers, and so is the range. So here's my g of x, all real numbers for the domain, and also g of x for the range, also all real numbers. So the domain and range for f of x, it seems to only be positives, but the domain and range for g of x seem to just be all real numbers. There's no errors whatsoever. And so remember, the phrase for that is simply all real numbers. So if you think about why that's the case, it piggybacks off of a conversation that we started in our last chapter. So if you recall from quadratics and your discriminant discussion, there's no such thing as square rooting a negative. And so it makes sense that the f of x, remember f of x was the square root formula. So it makes sense that f of x only had positives in it, because when it comes to square roots, you can't square root a negative. We saw that in our discriminant conversation from chapter 4. So if you think about it, that kind of makes sense as to why the square root formula had some errors in it and why the domain has to be positive. But for g of x, for whatever reason, a cubed root, all of a sudden, those errors don't seem to be there. Yeah, just keep that in mind. We'll talk about that more in a little bit. Okay, so now go to the next section. So when you go back into your Desmos for the next section, it's the 4th root and the 5th root. So remember that you have to go get your fancy root key. You can't just hit the square root button if it's not a square root. Desmos knows what a square root key means. And if you don't mean square root, then gosh darn it, don't use that key. You need to go to functions, miscellaneous, and then the nth root. Now you can say the 4th root of x plus 1. And then for the other one, g of x, or whatever function names they were. Yeah, f and g again. So g of x was the 5th root. So once again, functions, miscellaneous, 5th root, oops, 5th root of x plus 1. Okay, so you've got the functions. Once again, I'm going to give you a minute to convert those into tables. Hit the little wrench and turn them both into tables. And then you can type in the numbers that the table asks you for. And that way you can see what those values are supposed to be. So I'm gonna let you type that in. It's really important that you practice that piece. Don't just, copy what's on my screen. It's really important that your answers come out the same as mine. Half of using technology is using it correctly. So you have to know to use it correctly. Okay, but once you fill in the tables, you should come out with these responses. So the f of x, the first formula, you should have had some error messages on -10 and -5, but then at -1 you get an answer, 0 you get an answer, 1 you get an answer, 5 you get an answer, 10 you get an answer. Whereas g of x, when you type that one in, you should have gotten answers across the board. So you can make sure that your numbers match mine. But g of x doesn't have any error messages. Okay, so when you start thinking about the domain again, okay, remember, valid. So what's valid for f of x? Was -10 valid? No. Was -5 valid? No. Was -1 valid? Yes. Was 0 valid? Yes. Was 1 valid? Yes. Was 5 valid? Yes. Okay, so remember, your domain's job is to communicate what works. And f of x seems to work everything from -1 and beyond. So the way that I've noted that in my notation is by saying everything to the right of -1, aka everything bigger, technically, than -1. Everything from -1 and beyond works. Now the domain for g of x, so if you look at g of x for a second, what was valid on g of x? Was -10 valid? Yes. Was -5 valid? Yes. Was 0 valid? Yes. Was 1 valid? Yes. Was everything valid? Yes. So for g of x, it seems that everything is valid. Everything, everything, everything. Everything is valid. So we say all real numbers for that. So the domain for f of x has to be from -1 beyond, and the domain for g of x seems to be everything. And then what about the range? So now let's look at the answers, the outputs. Remember, the range means output. So if you look at the outputs on your first function, here's all your outputs. Oops, there we go. Here's all your outputs. Did you have any negative outputs? No. Did you have positive outputs? Yes. And specifically everything from 0 and up. That's what it means to be positive, is from 0 and up. So the range on f of x seems to just be positive answers. Everything above 0 is valid for the outputs. Notice I'm using the letter y because it's outputs. So for the first function, your range seems to be positive answers only. Now what about the range for g of x? Go look at g of x's table again, but this time specifically look at the outputs. Did you get negative answers? Yes. Did you get positive answers? Yes. So did anything not show up in your table? You got a little bit of negative, you got a little bit of positive. It seems to all be accounted for. So the range for g of x seems to be all real numbers. There's no errors on g of x for some reason. Okay, so, and then the vertical intercept, by the way, that's just, you can look at your table. So the vertical intercept means you plug in 0. By definition, I don't care what chapter you're in or what class you're in, by definition, for the vertical intercept, you just plug in 0. So that would be, oops, that would be this line right here. Plug in 0 and you get 1. So that's this. And then for the horizontal intercept, you're looking for where the output is 0. And I can tell that that happens right here at -1. So you can get both of your intercepts from the table. Certainly they're also in your graph right there and right there. So between the table and the Desmos, you're able to get your vertical intercepts and horizontal intercepts. Okay, so now what you have to start reflecting on though is why? Why are some of these functions producing errors and therefore having like finicky domains and ranges, and yet other functions are just all real numbers? Like on the first one, the square root had finicky errors, the cubed root, all real numbers. And then on the second one, the fourth root, finicky errors, but the fifth root, all real numbers. You're like, well, what the heck? How am I supposed to know when a function is going to have finicky errors or when it's not? Well, ladies and gents, if you think about it, the reason all comes down to what kind of root you're dealing with. What kind of root are you dealing with? So this little guy right here, let me get a color, here we go. This little guy right here, that is called the index of the root. Let me see if I can move this, there we go. So index of the root. So that guy right there, and see if I can draw an arrow. Where's my pen? This guy right there. That's not a very good arrow at all. Let me try again. Or do I have an arrow option? Oh, I do have an arrow option. Oh, but it's a straight arrow. That works. Maybe I can make this work. Let's see. There we go. How's that? So that little number, okay, is called the index of the root. So like in a square root, the index is 2. On a cubed root, the index is 3. On a fourth root, the index is 4, etc. So whatever that number is, it's called the index of the root. Well, as you saw in your discriminant conversation from the last chapter, you can't have square roots of a negative, right? Because any number times itself is always a positive. Well, ladies and gents, that exact same logic applies to any even root. Think about it. What is -2 squared? -2 times -2 is a positive, +4. But what is -2 to the 4th power? A positive answer. Oops, I meant -2. There we go. -2 to the 4th power, though, is a positive answer. What about -2 to the 6th power? Definitely still a positive answer. Because if you're talking about taking a number times itself an even amount of times, you're going to have just enough double negatives in there that the answer is going to be positive every single time. So as long as you have an even amount of copies, aka an even root, you're not going to have any negatives in that answer. You're going to have positives only. Now, if it's an odd root, on the other hand, check it out. -2 cubed, yeah, that's -8. If you take -2 and times it by itself an odd number of times, you get a negative answer. The same thing would be true if I took -2 to the power of 5. You get a negative answer. So because even amounts of copies always produce positive answers, that's why it's the even roots that have these weird domain restrictions. Even roots never produce negative answers. So even roots always have to have some kind of domain restriction that avoids square rooting, fourth rooting, whatever, negatives. Negatives simply don't exist in the even root realm. So back to your document here, there's another little vocab word, and that is for what that creature on the inside is called. So another vocab word. Let me try to size this down. Okay, so oops, let's make that see-through, shall we? There we go. So g of x, whatever that is, maybe change that color. There we go. So whatever g of x is, that will determine where your domain has to be. So if you think about it, on the first function, where's my other one? Not this one, the other one. Here we go. On my first function, there was just an x under there. And so notice on that one, since it was just an x, my domain was just x above 0. But now on this other one down here, when I had x plus 1 on the inside, right? X plus 1 was underneath there. Well, all of a sudden my domain was at -1. And you're like, wait a second, why is it -1? It says +1 in there. Why does it say -1 in my domain? Well, that's because, ladies and gents, so vocab word, this guy, where's my pen? Here we go. This guy right here, he also is a vocab word, and his vocab word is radicand. Okay, I don't know how to make the text purple. Can I make the text purple? Oh, maybe I can. There we go. Okay, so he's called the Radicand, all right? And it just depends on what's underneath there. It just depends on what your Radicand is as to what determines your domain. So here's like our little kind of summary takeaway message, if you will. So let's get rid of that. There we go. So first and foremost, right, number one takeaway message here is that odd index roots are simply all real numbers. Every time. No ifs, ands, or buts about it. If it's an odd root, then it's all real numbers and you just move on, because when it comes to odd increments, positives work, negative work, whatever, everything works. So if it's an odd index root, it's simply all real numbers. But if it's an even index root, then you have to make sure that the radicand, and when I say radicand, I just mean what's underneath the root symbol. Okay, that's what the radicand is whatever is underneath there. So the radicand has to stay positive, aka greater than or equal to 0. That's how you'll know where the domain has to be, is that the radicand will have to stay greater than or equal to 0. So if you think about that one from before, the fourth root, so f of x was the fourth root of x plus 1. So now in hindsight, obviously we saw on the table that everything from -1 and beyond is what worked. But now, even if you didn't have the table, first of all, you would notice, oh, hey, look, this is even. So right away, you know it's not all real numbers. And then how do you figure out the domain? Well, it's all based on this guy. So as long as x plus 1 stays greater than or equal to 0, then your domain is going to be happy. Now in this particular case, when does that happen? Oh, look at that. It happens for any number bigger than -1. -1 ends up being the cutoff point, so to speak. for that domain, because -1 + 1 is 0. That's a safe zone. And so that's the first number that works. -2, not so much. -1 though, yes. And anything beyond -1 would also work, because anything beyond -1 would also produce positive answers. Okay, so now that you have like the kind of the bulk of just how you're going to know where to even begin with domain and range and all that fun stuff, let's go look at those two graphs or those two functions on your activity sheet. So when you're graphing these, there's going to be a couple of key points and key characteristics that you have to know. So number 3 says graph the functions by stating the intercepts, if they exist. Tell me the domain. That should also say and range. Sorry, typo. Let's add that in, please. Domain and range, as well as the starting point of the function. Okay, so let me jot this down so that I can move my screen and still know what the heck I'm doing. Okay, so the first thing that you always want to look at on these is domain, because the starting point as I call it on that document, is based on your domain. So that function, f of x equals -2 times the square root of x minus 3 and then plus 5. Okay, so first of all, is this an even root or an odd root? What kind of root is this? You're like, well, I don't know. There's no number there, Bishop. Okay, I realize that, but that's because it's just a square root. If ever we don't put the index on there, that's because we just imply that it's a square root, a regular old square root symbol. But either way, it's a square root, so square root. It's even. It's definitely even. So since it's even, that tells you for sure that you need to pay attention to what your domain is, all right? It's not all real numbers. No, it is not. You have to look at your Radicand. Oh, get this thing out of here. There we go. You have to look at your Radicand, whatever's underneath the root, to see where your domain's going to be. So for the domain on this one, we'd have to make sure that x minus 3 stays greater than or equal to 0. Now in this particular case, when does that happen? Everything above 3. So that's the domain right there. Everything above 3 should be valid. Now the starting point, okay, so this is new. We haven't talked about this yet. The starting point then goes hand in hand with that domain. If your domain starts at 3, that means your graph starts at 3. So the question becomes 3 comma what though? Your domain starts at 3, fabulous, but what does it pair with? What's the actual point? So the way that you figure that out is you just take that 3 and plug it back into the formula. Of course, you can grab a calculator. You don't have to do this by hand, but it actually turns out to be hilariously easy, because check it out. The whole point of your domain, ladies and gents, hey guys, what's 3 minus 3? That's just a big fat 0. And what's the square root of 0? 0. And what's -2 times 0? 0. So all that's left is that little 5 right there. Ta-da! 5. Once again, you can plug this into a calculator, type it all in, you'll see for yourself, yes, the answer is 5. But if you think about it, it's gonna always be whatever that leftover number is, because everything else just gets zeroed out from your domain. Okay, so the starting point is at 3 comma 5. Okay, so we know that the domain is everything above 3. we know that, so let's see, where's my little pen? There we go. So, oh, that's right. I can't really write very easily on PDFs. Maybe I'll go back to whiteboard. No, you know what? Let's go to Desmos. Desmos, yes. Okay. Desmos. Clear all this out. Okay, so my function was -2 square root of x minus 3. Make sure you hit the arrow that gets you out of the radical and then say +5. It's up to you to make sure that the +5 is in the right spot, so to speak. Okay, so the domain, as you can see, is everything from 3, look, 1, 2, 3, 3, everything from 3 over, okay, so we already had that. The starting point is at 3, 5. Yep, look at that. Perfect. The horizontal intercept, right there, that ordered pair is the horizontal intercept. And then what about the vertical intercept? Where's the vertical intercept? Doesn't seem to have one. Let's see what happens if I plug in -2 times the square root 0 minus 3. Remember, vertical intercept by definition, you just plug in 0. Oh, look at that, it's undefined. Yep, it doesn't have one because look, 0 minus 3, that's a negative answer. Negative, can't square root a negative. So there is no vertical intercept. Yes, there's a horizontal intercept. Yes, there's a starting point. We know that the domain is everything to the right of 3. And then last but not least is the range. And the range is the very last thing you're going to do, okay, every single time, promise me. The range is the last piece where you sit back and you look at all your information and you say, what are the y values doing? My x values are above 3, but what are the y values doing? And you'll notice on this graph, my graph seems to live below, everything below the 5. 5 is your starting point, right? 3, 5. So 5 is your starting point. Everything below that is the range. So for your range, you would just say, now remember we're talking range, so it's the variable y. Please, please, please. Let me get my eraser and make space. There we go. Okay, so for your range, range, here we go, range. Your range are all y values below 5. Yes, indeed, all y values below 5. There was no vertical intercept, none whatsoever. And the horizontal intercept was at 9 1/4, I think. Is that right for the horizontal intercept? We can go back and double check in a second. I think it was at 9 1/4. Let's go back and double check. Where are you at? Yes, 9 1/4. Okay, so horizontal intercept, check. Domain, check. Range, check. Starting point, check. Vertical intercept, none. Okay, so that's that one. And then your graph, by the way, should just look exactly like this. You'd want to scale your axes appropriately so that everything fits. And then, yeah. And then the other one, let's go through that one a little bit quicker this time. So the other one was the 4th root, okay, so functions, miscellaneous, 4th root. And this time it's the 4th root of 3x plus 7. Use your arrow to get out of the radical, take away 4. Okay, so right away you can produce a graph. And there's a couple of things that you can notice, you know, by just looking at the graph. So on this particular one, there's definitely a vertical intercept at 0, -2.3. But let's talk domain and starting point. So for the domain and starting point, first of all, is this function going to have a finicky domain, or is this function going to have all real numbers? So if you look at the function, let me clear this out. If you look at the function, it was a fourth root, wasn't it? My memory is correct. That was a fourth root function. So is it going to be all real numbers? Heck no. That's an even. Fourth root, that's even. Fourth root. So it's definitely not all real numbers. This one needs some investigation by you and I. And remember that the domain comes from what we call the radicand, whatever's on the inside underneath the root. So for this one, the domain will be whenever 3x plus 7 is greater than or equal to 0. We have to make sure that the radical stays positive. So when will that happen? So if I subtract 7 from both sides, oops. Subtract 7 from both sides, divide by 3. It's at -7/3. Okay, so as a decimal, that's what? -2.3. Repeating. So approximately -2.3. Okay, so this is your domain. Domain has to be above -7/3. But where's the starting point? So now you know that it's -7/3 because that's where your graph starts, but what does it pair with? Well, again, you can plug it back in because yes, that is where it comes from. 3 times -7/3 plus 7, all of that would have to get fourth rooted and then take away 4. But guys, think about it. This isn't a trick question, but ready? What's 3 times -7/3 plus 7? Sounds really weird, I know. But it's one big fat happy 0. That's the whole point of your domain, is that you're making sure it's above 0. So when you plug -7/3 back in, you're gonna get 0. But then what about him? He's still there, right? So even though the radical is one big fat happy 0, that's the whole point, you still have the -4. So that's your starting point. So the starting point of that graph is at -7/3, comma -4. -7/3, comma -4. -7/3, comma -4. Where's the comma down there? There we go. Look at that. Perfect. Okay. So you've got your domain, everything to the right of -7/3. You've got your starting point. What about your range? Now that you have this nice holistic view of the graph, you know exactly where the starting point is. Where's the range of this purple graph? Well, it seems to be everything above -4. That dot right there is at -4, right? Right. And the graph is everything above that mark. So your range is everything above -4. So how do we say that? Range. Let's get a different color here to try to differentiate. Okay, so the range is everything above -4. And then the intercepts, we'll talk more algebra about the intercepts in another lesson, but for now, the intercepts, you can get them on Desmos. So if you just go back to your Desmos, the vertical intercept is right there, -2.373. Of course, you could get that answer by just plugging in 0 for x. Remember, by definition, there we go, right there. So -2.37, that's the vertical intercept. The horizontal intercept, at first you're like, well, gosh, does it have one? And this is where the algebra is gonna help. We'll do algebra in the next lesson. But yes, it does have one. Check it out. It's at 83. Yeah, 83. When you first look at that graph, you're tempted to be like, I don't even know if this has an x-intercept. Well, don't jump the gun because it does. It's just way out there. And I realize that's kind of obnoxious to have to scroll around looking for it, but that's why we have algebra that we'll do in our next lesson. But nonetheless, for today, there are intercepts. There's a horizontal intercept at 83, and there's a vertical intercept at 0, negative 2.37. So domain, check. Range, check. Start point, check. Vertical intercept, check. Horizontal intercept, check. Okay. So that is how you'll know the domain and range of these graphs. Notice I only did even root examples because, ladies and gentlemen, if this were an odd root, we would just say all real numbers and move on. I suppose if we wanted the vertical intercept, we would just touch it. And if we wanted the horizontal intercept, we would just touch it. But as far as the domain and range and the starting point goes, none of that. It's just all real numbers, move on. So I'm not even doing examples for that because honest to goodness, if this were an odd root, pretend for a second that that said cubed root, domain, all reals, range, all reals, vertical intercept, touch, horizontal intercept, touch, move on, next problem. So I'm not spending a lot of time on odd ones, and your homework only has 1 or 2 in there that are odd because they're like way simpler and way quicker than the even ones. So we spend the large majority of our time talking about the domain and range for even radicals only, because even radicals are the ones that are much more finicky and therefore deserve our time and attention and focus. All right. Thank you guys for your time. Hopefully that made sense. And I will see you guys soon. Thank you.